Hey there, my name's Cole Bowden. In this video, we'll talk about scaling Firebolt engines, the different dimensions in which you can scale a Firebolt engine, and how to correctly scale an engine for your workload. Now in Firebolt, there's a number of different dimensions in which you can scale your Firebolt engine. Some of these are vertical, some of these are horizontal, and some of them aren't really either, and we're going to try and get into them. The first and simplest dimension that you can scale a node in Firebolt is called node type. This is the size of your node. It's small, medium, large, or extra large. This is vertical scaling, which means that as you increase your node type, the individual machines in your engine are getting more powerful. And in fact, each jump up this node type scale is doubling the size and power of a node. So while a small engine might have some amount of RAM and disk and CPU cores, a medium engine will have double of all of those. And a large is double that again, and extra large is double that again. So cost also doubles in turn with this. You can also scale your number of nodes. So when you have a node type, you can select 1, 2, 3, or as many nodes as you want from 1 to 128. Now, scaling out like this is called horizontal scaling traditionally, and it's adding more machines to your Firebolt engine so that you can distribute and parallelize the processing of a given query or a number of queries. There's also finally this notion of clusters. You can scale the number of clusters in your engine. A cluster is an identical composition of node type and number of nodes, and you can have from 1 to 10 clusters. This is generally good for concurrency when you have many users or many clients submitting queries at the same time. Because you're once again adding more machines to your engine, this is also horizontal scaling. There's a final type of scaling for Firebolt engines that I'm going to touch on a little later in this video, but it's called compute family. And there's different options for compute family that change exactly how powerful each node is in regards to the different resources on that. So a compute optimized compute family has proportionally more CPU cores to other resources. We also have a storage optimized compute family that has proportionally more memory and disk space relative to CPU cores and other compute families. So that's pretty nuanced and complicated, and there's a standalone FireEdge video and knowledge base article that goes more into compute families. So I'm going to disregard it for the time being, but we'll touch on it a little later. So now the question is, how should you go about scaling your engine for a given workload? We can start simple. Generally speaking, you're going to want to start by scaling your node type. It is the most reliable way to improve query performance in Firebolt, as it gives you a single, more powerful node that can process a query faster. When you distribute across a number of nodes, you're going to incur a little bit of overhead, and by keeping your work consolidated to a fewer number of nodes, you minimize that overhead to improve performance. So scaling your node size is the best starting place and where you should generally begin when you're looking to scale an engine. However, number of nodes still has an important role to play, because when you scale a node type, as mentioned, you're going to double the entire processing power of your engine. And sometimes you don't need that. If, for example, you're running an engine with a single medium node and you need, 25% or 50% more power, going from one medium node to two medium nodes is going to double that. But you could downgrade to a small node type and then run 3 small nodes. That way you're improving your processing power by 50% and instead of by 100%, making sure that you're not spending on excess capacity that you don't need. So number of nodes helps you with granular scaling, and though there is a little bit of overhead, the cost efficiency can sometimes be worth incurring it because it is very, very fractional. The other thing that number of nodes is good for is ingestion. When you're reading from files and ingesting data into Firebolt, opening and reading from those files can be a pretty big bottleneck when you have a single node engine. By adding more nodes to your engine, you can parallelize this process and speed that up. So when you're ingesting large quantities of data, we recommend adding more nodes to your engine, and you can increase to a pretty large number of nodes, especially if you have a large number of small files. Clusters, as stated previously, are what you scale for concurrency. They route queries, an engine will route queries into different clusters, and each cluster can process a query independently. Adding more clusters to an engine does nothing when you have few queries being submitted at a time. If there's only one query and you have 2 clusters, one cluster is going to sit idle while the other cluster runs that query. So you want to make sure to scale clusters only when you have multiple users or clients submitting concurrent query workloads. You can also enable auto scaling so that you can have a minimum of 1 cluster and add more clusters as the workload increases. And that can be handled for you by Firebolt so that you don't need to worry about clusters as much. So in short, start by scaling node type, scale your number of nodes for ingestion or when you want granular scaling, and let auto scaling on clusters do the work for handling concurrency. To do a brief demo, I'd like to show you Firebolt scaling in action. I've loaded up the FireScale dataset with a 1 terabyte table, and I've got 4 different engines ready to go. One with a single small node, one with 2 small nodes, one with a single medium node, and one with 2 medium nodes. Now, I've written a query here that's one of the more complicated queries from the FireScale benchmark, and it's going to take a little bit on the single small node engine. And then we'll run it again on the larger engines to see how Firebolt scales near linearly with increased compute power. This query on the single small node engine, you can see, took 6.52 seconds. So when we double to a 2 small node engine, we're going to expect that query to run in approximately 3.26 seconds. I'm going to run that query here, and you'll see that it took 3.22 seconds, actually a little better than linearly here. I'll also try a 1 medium node engine. This is the same amount of compute power, but instead of having 2 nodes and distributing it, we're just using 1 node here. And you can see the medium node took 3.29 seconds, also right next to that 3.26 seconds we expected. Now we can add more medium nodes to this engine as well. We're going to expect this to get cut in half yet again. So if this scaled perfectly linearly, we'd expect it to be 1.65 seconds. And if I run the query on this engine, you'll see that it took 1.64 seconds. So Firebolt scales very well in all of these dimensions, and whether you're adding nodes or scaling vertically, it's not going to make a huge difference, but we do recommend scaling vertically first. The other thing I'd like to show off is how adding clusters can scale for concurrency. I'm going to run the concurrency benchmark that we set up in FireScale, but an abbreviated version that won't take very long. This run is on a single small node engine. So we're just going to run for 15 seconds and see how many queries that engine can churn through in that time. You'll see that you're using K6 to do this. It's a workload testing tool, and it's just saturating this engine with 20 queries running at the same time. Now here you can see that in this 15 seconds, we were able to run 1,766 queries. Now I'm going to set this up on an engine with 2 clusters. I'm also going to give it a larger workload, as I want to make sure that it is being fully saturated by the queries that we're running. So you'll see that we're using 80 VUs instead. We're going to kick this benchmark off, and K6 is going to get to work saturating this engine with 80 concurrent queries at a time. And where we saw 1,766 queries on that first run, we should now see about 3,500 queries on this run. And at the end of these 15 seconds, you see it was 3,476, near linear scaling. One final thing to note as part of this demo is that compute family configuration option that I hinted at earlier. Now, we recommend storage optimized as a default in Firebolt, and all of the demo up to this point has been on storage optimized engines. However, you can swap to a compute optimized compute family for your engines under certain scenarios where CPU is serving as your main bottleneck, as a compute optimized engine will cost half as much as a storage optimized engine and come with the same amount of CPU power. So, for example, I'm running a simulated load of concurrency here, where I have my CPU utilization at 100% and my memory and disk are both very limited utilization. This would be a great opportunity to swap to a compute optimized engine. And in fact, I could swap to a compute optimized engine and increase the size and have better performance for the same or lower cost in this scenario. Because Firebolt scales so well in all of these different dimensions, it's hard to go too wrong in choosing how to scale as long as you're providing enough resources for your workload. However, when scaling, it's good to be deliberate and strategic about what you're scaling and what your use case is. As discussed, node type is best for general purpose scaling, and when you can increase node type, that's a great place to get started. Increasing the number of nodes is great for ingestion, or when you want more granular scaling, such as when you have a single M node engine and need 50% more power instead of 100% more power. And clusters, of course, are for concurrency, and when you have many different users or clients submitting a large volume of queries to your engine at one time. Now, there's a lot more to be said about how to scale your engines that can't really be covered in a brief video with an overview like this, so I'd encourage you to go check out the Firebolt product, get your hands on, and see how different engine sizes perform on different datasets and different queries, and that'll give you a better idea of exactly how it behaves. Thanks for watching.